Okay, this lesson is about using fundamental trigonometric identities. The fundamental trigonometric identities are needed for calculus. So that's why we start to study them in math analysis. All the identities in your textbooks are on page 350, and by the end of this unit, you'll have them memorized. It seems daunting at first, but you'll practice it enough that I have confidence that you can memorize it. So what I'm going to do is evaluate the following trigonometric functions. And before, when we did this, we would have drawn a right triangle, reference triangle, in the correct quadrant, labeled everything, and used Pythagorean theorem. And you can do that to check your work. But the idea behind this concept is that it's a process. You need to show that you understand, and not all the time can you have numbers, so you'd have to be able to do this process without numbers. So my first example, I'm given that the sine of theta is equal to 3 over 4. So that means my opposite side is 3 and my hypotenuse is 4. And it also says that cosine is positive. Sine is positive in the first and second quadrant. Cosine is positive in the first and fourth quadrant. So I know that this function has to be in quadrant 1. So I'm going to write that down. And that's just a little check for me later on. So now I want to find cosecant of theta. So if the sine of theta equals 3/4, I know because of the reciprocal identity, sine of theta is equal to 1 over cosecant of theta. So cosecant of theta is equal to 1 over sine theta. So then cosecant theta, if I have 1 over 3/4, I'm going to take the reciprocal of 3/4 and say it is equal to 4/3. So cosecant of theta is equal to 4/3. And I'm just going to go back up and look, and I said this is in quadrant 1. Cosecant is positive in quadrant 1, so that is the correct answer. My second example, once again, I'm given sine and I'm given cosine, but I want to find tangent. So I know sine is negative. Sine is going to be negative in the third quadrant and the fourth quadrant. Cosine is positive. Cosine is positive in the first quadrant and the fourth quadrant. So this is 3 and 4, this is 1 and 4. So I know that the angle has to be in quadrant 4. So since I'm given sine and cosine, I want to find tangent. I can use my quotient identity. I know that tangent theta is equal to sine theta divided by cosine theta. So I know my sine theta is equal to 7 over 9, negative, and my cosine is 4 square roots of 2 over 9. When you take anything divided by a fraction, you're going to flip the second fraction. So I'm going to take the reciprocal of the second fraction and multiply. So I have negative 7 over 9 times 9 over 4 square roots of 2. If I were to multiply this out, I'd have a 9 in the numerator and the 9 in the denominator. And I know that's equal to 1. So right away, I'm just going to go ahead and get rid of the 9's. And I have tangent theta is equal to negative 7 over 4 square roots of 2. I'm going to rationalize the denominator. So I get negative 7 square roots of 2. 4 times the square root of 4, which is going to be 4 times 2, is going to be 8. So now my tangent of theta is going to be negative 7 square roots of 2 over 8. And then I'm just going to go back up and check again. I said this was in quadrant 4, and I have the negative there, so that's correct. So I've used a reciprocal identity and I've used a quotient identity. The next one I'm going to do, example 3, I'm given cosecant is 5 and tangent's positive. I know cosecant is positive in the first and the fourth quadrant. Tangent is positive in the first and third quadrant. So I know that this has to be in quadrant 1. Since I have cosecant and I want to find cotangent, there is a Pythagorean identity. That says 1 plus cotangent squared theta is equal to cosecant squared theta. And we've talked about this before in class, but let me remind you, cotangent squared theta is going to be cotangent theta multiplied by cotangent theta. It's not that the angle is squared, it's that the cotangent is squared. So I have cosecant, so I know 1 plus cotangent squared theta is equal to 5 squared. I'm replacing cosecant theta with 5. So 1 plus cotangent squared theta is equal to 25. I'm going to subtract 1 and I get cotangent squared theta is equal to 24. Now I can take the square root of both sides. And this is why I want to know the quadrant. When I take the square root of both sides, I'm going to get a positive and a negative. So I get cotangent theta is equal to plus or minus the square root of 24. Since I'm in quadrant 1, I know cotangent is positive in quadrant 1, so I want the positive version of this. And I know the square root of 24 is going to break down. It'll be the square root of 4 times the square root of 6. So I know positive 2 square roots of 6. And there's my cotangent. So now I've used reciprocal identity, I used quotient identity, and I've used Pythagorean identity. Let me do the last example. This one says secant of pi over 2 minus theta is equal to negative 5/3. Since I want to find sine theta, I know secant is going to be negative in the second and third quadrant. So I don't know if this is second or third quadrant yet. So I'm going to use, this looks really strange, but this is a cofunction identity. So let me write this down. Quadrant 2 or 3. So I'm going to say the cofunction identity is telling me secant of pi over 2 minus theta is going to equal cosecant of theta. So that means if this is equal to negative 5/3, then cosecant of theta is equal to negative 5/3. Cosecant is negative in the third and fourth quadrant, so I know that this now is not the second quadrant, it has to be quadrant 3. And I want to find sine theta, so I'm going to use the reciprocal identity. And I'm going to say sine theta is equal to the reciprocal of cosecant, so it's negative 3 over 5. And I said this was in quadrant 3, and that is negative. The best way to work these is to go ahead and just practice a lot of them. And you can always double check by drawing the triangle in the coordinate plane. But for any quiz or test, when I'm asking you to do this information, you're going to have to show the steps the way I did.